Hello, this is Tarun from Data Science Department of Institute of Aeronautical Engineering. The topic is data cleaning from the subject of DMR, that is data management and representation. Uh, the general topics which we are covered in this presentation are data cleansing or data cleaning and importance, process, quality screens, data cleaning and data science, steps to perform the data cleanliness. Data cleansing. Data cleansing or data cleaning is the process of detecting and correcting or removing corrupt or inaccurate records from a record set, table, or database and refers to identifying incomplete, incorrect, inaccurate, or irrelevant parts of the data and then replacing, modifying, or deleting the dirty or coarse data. Data cleansing may be performed interactively with data wrangling tools or as batch processing through scripting or a data quality firewall. After cleansing, a data set should be consistent with other similar data sets in the systems. The inconsistencies detected or removed may have been originally caused by user entry errors, by corruption in transmission or storage, or by different data dictionary definitions of similar entities in different stores. Data cleaning differs from data validation in that validation almost invariably means data is rejected from the system at entry and is performed at the time of entry rather than on batches of data. The actual process of data cleansing may involve removing typographical errors or validating and correcting values against a known list of entities. The validation may be strict, such as rejecting any address that does not have a valid postal code or with fuzzy or approximate string matching, such as correcting records that partially match existing known records. Some data cleansing solutions will clean data by cross-checking with a validated dataset. A common data cleansing practice is data enhancement, where data is made more complete by addition related information, for example, appending address with any phone numbers related to the address. Data cleansing may also involve harmonization or normalization of data, which is the process of bringing together data of varying file formats, naming conventions and columns, and transforming it into one cohesive data set. A simple example is the expansion of abbreviations STRD etc. to street, road, and etc. Data cleaning and importance. Data cleaning is a crucial step in the machine learning pipeline as it involves identifying and removing any missing, duplicate, or irrelevant data. The goal of data cleaning is to ensure that the data is accurate, consistent, and free of errors, as it incorrect or inconsistent data can negatively impact the performance of machine learning model. Professionally, data scientists usually invest a very large portion of their time in this step because of the beliefs that better data beats fancier algorithms. Data cleaning, also known as data cleansing or data pre-processing, is a crucial step in the data science pipeline that involves identifying and correcting or removing errors, inconsistencies, and inaccuracies in the data to improve its quality and usability. Data cleaning is essential because the raw data is often noisy, complete, and inconsistent, which can negatively impact the accuracy and reliability of the insights derived from it. For decision making, the integrity of the conclusions drawn heavily relies on the cleanliness of the underlying data. Without proper data cleaning, inaccuracies, outliers, missing values, and inconsistencies can compromise the validity of analytical results. Moreover, clean data facilitates more effective modeling and pattern recognition, as algorithms perform optimally when fed high quality, error free input. Additionally, clean datasets enhance the interpretability of finding, aiding in the formulation of actionable insights. Process. Data auditing. The data is audited within the use of statistical and database methods to detect anomalies and contradictions. This eventually indicates the characteristics of the anomalies and their locations. Several commercial software packages will let you specify constraints of various kinds using a grammar that conforms to that of standard programming language, example JavaScript or Visual Basic, and then generate code that checks the data for violation of these constants. This process is referred to below in the bullets workflow specification and workflow execution for users who lack access to high-end cleansing software. Microcomputer database packages such as Microsoft Access or FileMaker Pro will also let you perform such checkers on a constant by constant basis interactively with little or no programming required in many cases. Workflow specification: the detection and removal of anomalies are performed by a sequence of operations on the data known as the workflow. It is specified after the process of auditing the data and is crucial in achieving the end product of high quality data. In order to achieve a process proper workflow, the causes of the anomalies and errors in the data have to be closely considered. Workflow execution: in this stage, the workflow is executed after its specification is complete and its correctness is verified. The implementation of the workflow should be efficient even on large sets of data, which inevitably poses a trade-off because the execution of a data cleansing operation can be computationally expensive. Post processing and controlling: after executing the cleansing workflow, the results are inspected to verify correctness. Data that could not be corrected during the execution of the workflow is manually corrected. If possible, the result is a new cycle in the data cleansing process where the data is audited again to allow the specification of an additional workflow to further cleanse the data by automatic processing. Quality screens. Quality screens, part of the data cleansing system, is a set of diagnostic filters known as quality screens. They each implement a test in the data flow that, if it fails, records an error in the error event schema. Quality screens are divided into three categories: column screens, structure screens, business rule screens. Column screens are testing the individual column. Example: for unexpected values like null values, non-numeric values that should be numeric out of range values, etc. Structure screens: these are used to test for the integrity of different relationships between columns, typically foreign or primary keys, the same or different tables. They are also used for testing that a group of columns is valid according to some structural definition to which it should adhere. Business rule screens, the most complex of the three tests. They test to see if data may be across multiple tables, follow specific business rules. An example could be that if a customer is marked as a certain type of customer, the business rules that define this kind of customer should be adhered to. When a quality screen records an error, it can either stop the data flow process, send the faulty data somewhere else than the target system, or tag the data. The latter option is considered the best solutions because the first options required that someone has to manually deal with the issue each system it occurs, and the second implies that data are missing from the target system integrity and it is often unclear what should happen to these data. Data cleaning in data science. Data cleanup is an integral component of data science, playing a fundamental role in ensuring the accuracy and reliability of data sets. In the field of data science, where insights and predictions are drawn from vast and complex data sets, the quality of the input data significantly influences the validity of analytical results. Data cleaning involves the systematic identification and correction of errors, inconsistencies, and inaccuracies within a dataset, encompassing tasks such as handling missing values, removing duplicates, and addressing outliers. This meticulous process is essential for enhancing the integrity of analysis, promoting more accurate modeling, and ultimately facilitating informed decision making based on trustworthy and high quality data. Steps to perform Steps to perform data cleanliness. removal of unwanted observations, fixing structural errors, managing unwanted outliers, handling missing data. Uh, Removing of unwanted observations, identifying and eliminating irrelevant or redundant observations from the dataset. The steps involve scrutinizing data entries for duplicate records, irrelevant information, or data points that do not contribute meaningfully to the analysis. Removing unwanted observations streamlines the dataset, reducing noise and improving the overall quality. Fixing structural errors, address structural issues in the dataset such as inconsistencies in data formats, naming conventions or variable types, standardize formats, correct naming discrepancies, and ensure uniformity in data representation. Fixing structural errors enhances data consistency and facilitates accurate analysis and interpretation. Managing unwanted outliers, identify and manage outliers which are data points significantly deviating from the norm. Depending on the context, decide whether to remove outliers or transform them to minimize their impact on analysis. Managing outliers is crucial for obtaining more accurate and reliable insights from the data. Handling missing data, devise strategies to handle missing data effectively. This may involve inputting missing values based on statistical methods, removing records with missing values, or employing advanced imputation techniques. Handling missing data ensures a more complete dataset, preventing biases and maintaining the integrity of analysis. There are basic schematic diagrams of data cleaning. Just go through this. I hope this presentation will helpful for your further information of data cleansing or data cleaning in data science and other factors. Thank you. Represented by Tarun Gaud Muddam from Data Science Department of IARE. Thank you very much.